Okay, another divisibility one. So once again, we start and we prove that P1 is true. So wherever n is, we replaced it with 1. Check my sums, see that that is correct. Okay, we get this is equal to 35, which becomes 7 times 5, therefore clearly divisible by 5. So we've got P of 1 is true. We're now going to assume that pk is true. So once again, we come back here and wherever n is, we replace with k. And because we're assuming it's true, that means we say it equals 5 times some sort of integer. So do make sure that you're actually saying that is the case. Okay, here we go. We now want to prove pk plus 1 is true. So I've put k plus 1 wherever n is. So k plus 1 plus 2 gives me the k plus 3, and 3 times k plus 1 gives me 3 to the k plus 3. All right, so I'm going to try and separate these. So I'm going to keep my k plus 3 for now. Because I want to try and substitute in with pk, I need to rearrange my work so that I either get a 2 to the k plus 2 or a 3 to the 3k. I'm going to go for the 3 to the 3k. So we can see here, I can separate this to be 3 cubed times 3 to the 3k. Okay, again, timesing by the same base. When I times by the same base, I add the powers. So that is the same as this. I've just separated it using index laws. Okay, we'll keep this 2 to the k plus 3. 3 cubed is 27, and I'm now going to replace this. So 3 to the k is going to equal 5a minus 2 to the k plus 2. So that is where we have used, right, using pk. I think I've forgotten to write that in a couple of the other ones. Okay. And away we go. So I've got 2 to the k plus 3 plus 27 lots of 5a. Again, I'm not tempted to actually work out what 27 times 5 is because I know I have to pull 5 out as a common factor. And then I've got 27 lots of 2 to the k plus 2. So we look and we see, okay, this bit here is pretty good because I can see I can pull out a common factor of 5. However, this and this is so far no good. What I'm going to try and do is make 2 to the k plus 3 be a similar term to that. And by now, we're pretty confident, I hope, by separating these. So again, do we agree that 2 times 2 to the k plus 2 is indeed 2 to the k plus 3? And I'm taking 27 times 2 to the k plus 2, and I've got my 5 lots of 27a. Alright, so we have now got similar terms because I've got 2 lots of 2 to the k plus 2, and then I've got minus 27 lots of 2 to the k plus 2. So if we rewrite this now, gather our like terms, 2 lots take 27, that's a minus 25 lots of 2 to the k plus 2 plus 5 lots of 27a. I guess it looks a little bit neater if we put the positive out the front. But we can also see clearly that I've now got a common factor of 5, which I can pull out. So 27a minus 5 lots of 2 to the k plus 2, and we've already established that that is indeed an integer. So therefore, pk plus 1 is true. it is indeed divisible by 5. But the trick here is separating your expressions there. Okay, so know that you can separate 2 to the k plus 3. We can separate that to be 2 times 2, because when you times it by the same base, you add the powers. And why did I choose that? Why didn't I write that as 2 to the 3 times 2 to the k? Well, the other term that I had wasn't 2 to the k, it was 2 to the k plus 2. So look at each of the terms that you have, and that will tell you where to go with that. All right, and therefore, write your statement. Never forget to write that statement.